Everyone, thanks for coming. Medra, thanks for having me. My name is Jeremy Elser. I'm the founding CEO of a biotech company called Theseus. So we're developing traditional biologics across a couple of indications. And I want to talk about a problem that I think every lab has, whether it's big pharma, academic, small pharma like myself. And this is the idea that once the scientist who did the experiment leaves your organization, the value of that science to you degrades really fast. And wow, giggles. And that's because it is almost impossible, even for someone who is trying to write down exactly what they did in all of its glorious metadata. And so you always find yourself asking 6 months later, hey, how much arginine was in that sample? Was this that run or that batch? And it's just, you can't ask a scientist to copy down all that information up front. They don't have time for it. They won't do it. They want to get to their chart, and they don't know exactly what they need to do. So I'm going to show you how we implemented in our lab better data capture practices. And I'm an FDE, a forward deployed engineer at Palantir, so I did this on the Palantir software. You can use Palantir for your lab too. You don't have to do exactly what we did. But the cool thing about being both at Palantir and having my own biotech is that I can show you what we built on our real data, what our scientists log into like every Tuesday. So this is our ELN. We're using SciSure. And this is pretty good data capture for a scientist. This is about the best you're ever going to get. They copied in a protocol. The charts that they make, the Excels that they make are really whatever they feel like it. Like a bench scientist, unless they have a computational background, when they do a 6-well plate, they think in terms of an Excel with 6 wells. Like they don't think in terms of tables. So it's really hard to extract information out of this with AI or get them to conform because they're just not going to conform to any type of template. In fact, even with this scant template, I recently had somebody who just added 5 columns to the left. And I was like, why did you do that? And it's like, well, because it looks better when it's centered. It's like it pushed everything out of where the AI was looking for it. But so this is an example of what we get as input. And we want to extract all the information out of this as we can. So now we're in my Palantir Foundry instance. And these are tools that we've made for our lab. And I go into my Experiment Explorer, and I'm going to look for my study. This is my lab. And I'm going to search for, this is a cell proliferation assay. Yep. And so I'm going to find that study. And note, I never asked the scientist to say this is a cell proliferation assay. That was inferred and classified by the AI. And I'm going to go find that study. I'll get this one. And if you're familiar with Palantir at all, like it's end-to-end data ecosystem software. This is not a Palantir advertisement talk. You can ask over. You can basically build anything that you want, and that including these UIs. And you can see what I've extracted from this experiment here. It identified it's a cell proliferation assay. It identified that we're working with HOXD4 as a protein, which is really cool, because then I can say, show me all the other times we did cell proliferation on HOXD4 as our drug. It extracted a protocol. It extracted time points. That's really helpful because I'm going to show you some automated automation. So the fact that it realizes that this is a longitudinal study means it can make those charts automatically. And then my favorite part of this is I call it the automatic Jeremy, which is basically poke the scientist in real time and say, please, oh, you didn't tell me what the media was. You didn't tell me this. You didn't tell me what that was. And for me to actually write down all the criteria I would want for every type of assay that we do is impossible. But the AI, I can give it more generic guidelines. You are trying to reproduce this paper. What do you need? And then this kicks off a procedure. And then just because it's Palantir Foundry, you can see all the things that it's linked to. So you can see all the other cell proliferation assays we do. You kind of get that all for free because I'm using Palantir. And then this is a workflow where the scientist can come in and say, it's got data capture in here. So complete. I used lots of arginine. Arginine's on my mind as of this week. You can't tell. OK, so then we're still asking the scientists to do a little bit of extra work, and that's not something that they want to do. So we've got to make it up to them. And in return, what they get is every chart that they could possibly want to make, every statistical analysis can be made for them. And we operate as a CRO, so we communicate in PowerPoint. But they can just flick through, like, here's all the statistics. And honestly, like, your average scientist might not know how to do a Kaplan-Meier or whatever it is that they're doing. So we just add more statistical capability and then click rerun on all of our historical data, and you get all these charts. Not every chart is going to be interesting, but they can find the one that they want. And they get that for free. So they've been rewarded for participating in the system. So this is all built on top of the Palantir ontology. If you've heard the word before, and this is maybe the only city in the world where I can reliably assume that you have, you've probably heard about the Palantir ontology. This is how Ship of Theseus operates, from our raw data sources from our ELN over here in SFDC to the data transformations. This is all automatically maintained. It's a really cool tool for developers because you can see time-lapse builds and build failures and things like that. But this is the Ship of Theseus ontology. It is different than if any other company or any other lab made their ontology. We're constantly refining it. But you can see that these are like the nouns and verbs of how we operate. So we use elab, like I said, and we've got all these different objects here that link to each other automatically. We use Team Gantt for assigning people to things. We actually operate as a CFO, so we have some Salesforce stuff. We've got science things. Here's our QMS resolutions, like I demoed, different projects, emails, grants, everything in here, and it all links together. And this idea of like a global customer, which only exists in our Palantir Foundry instance because it links everything together here. Then, like, what else can we do with all this information? Because we know that like the frontier models, they're actually really good at answering questions based on literature. The harder part is how do we get like our information into them? Because that's the stuff that's like the Wild West and messy. So here, I've taken apart our. I'm like ingesting all of our documents. This is a document that was made by a scientist. It's our final report. And I've got prompts running to pull this out, and you can see that it's summarizing for me, so I can come back to it. So this is really just doing the same thing at the experiment level, but one level up, and we just keep aggregating, and you can get to the underlying reports. So here's like the actual charts that were made, and you can see that there are, it's like it's analyzed this, but it's also, it can read these charts. And so it can put into text. If I went back to the text here and search for Kaplan-Meier, it'll tell you like what happened in the summary. So it can read this chart. So now you can like really start summarizing your internal data, and we can do a lot with that. We can figure out what our internal status is. One of the cool things we can do is use it to write or evaluate our pre-IND, which is like what we're doing right now. Like we're just about to submit it. And so this is another widget in Palantir. It's called Logic, and it's a place to stream together prompts. And so here, pretty simple prompt. I did not really optimize this very hard, but I gave it access to tools like the ontology. And so I can look in here and say, like, yeah, you can pull FDA guidance, pull the therapeutic from where we have that information, and because it can navigate the ontology the same way, like this is kind of how humans think about the world. It's object-oriented. Like you don't hire an intern and tell them about data sets and databases. You hire them to say, like, we have experiments, and they get grouped into projects. So like LLMs navigate the same way, and so you can restrict the context by giving it access to the group of experiments that we did. And so you make these sequential prompts. And so here I've got, this is our current, we're using it for HOXB4 for neutropenia. And this is actually an assessment of an IND, not a pre-IND, but it'll go through and tell me, where are we? Are we close enough to submit? And now we're not, because I said that we're going to our pre-IND, so most of these say not satisfied. But you can see what we've got and where the gaps are, and this is going to guide our upcoming experiments. Cool. You can also use this to write protocols. So this was kind of like my John Henry moment, trying to compete with the machines. Because I fancy myself as a PhD being pretty good at writing protocols, but you have to read papers, and then you read the papers under the papers, and you see what protocols are common, and it's a really lengthy process. But I can say, show me for alopecia and HOXC13. This one's interesting. Basically, write my protocol. And so I've gone through and I've coached it a little bit. I say, okay, look at the journal articles that we've parsed, and I give it guidance. So there's a journal article object, look in the methods. I did have to teach it some things like it doesn't have an inherent knowledge of what a cohort is or what a positive control is. So you put things in there to say, this is, you need to have a positive control. I want an in vitro model. I want an in vivo model. And it's cranking through that right now. And you can see it's reasoning in there. And what it's going to get to, and actually what it just got to, is it's going to say, yeah, here's the models that you should use. Here's your dosing regimen based on your internal and external data. Somewhere in here, if I control F, I bet I'll see the word minoxidil, which is a really good positive control. Let me know if you see it. Yeah, it's in there. There it is, minoxidil. Yep. So like it's pretty smart. And honestly, like this would have taken me several weeks to do, and now I can just do it instantly. Um, so we're using this thing for a lot of stuff, ever growing. What's brand new is the first example I showed you was a little bit like we organized like just the barest of templates, and they can really butcher it. And we're going through one by one like we did pharmacology. So like what we've been working on this week is, can we get rid of that? Can we just ask the AI, like, look at this Excel and you figure it out? And can you make the charts? And so far the answer is like not really. But with a little bit of coaching, there's a middle ground, and it's getting better. And it does get, sometimes it makes some pretty impressive charts. And then we're also using it to manage our collaborations. That's like the new work that's coming in now. So you can see like there's this ever-growing corpus. But the main thing that I find from this is I know so much more about the experiments that I'm doing, and I will continue to know that even after the scientist leaves. And while that's really great for your lab or your pharma company, I think that this could actually be the core of the reproducibility crisis, because I don't think that most studies, like that's the idea that you try to reproduce somebody else's work, somebody publish it, and you just can't. I don't think it's actually that all the scientists are lying. I think that it's actually I had an experience where I called the author of a paper. She's now 70 years old. I'm lucky, like a couple more years and this wouldn't have worked. And she just explained to something that wasn't listed in the 2 paragraphs of methods you get in the paper. But if you could just like port it to the journal when you want to publish, port it to the investor when they want to invest in you. Like, show me the raw, show me how you get to the final figure. My hope is that this will obviously move science forward for all the people doing it in this room, but also I think this is pretty cool for the reproducibility crisis.